Yeah, good morning, students. Say good morning, at least. నేనేమన్నా కొరియన్ లాంగ్వేజ్ మాట్లాడి నేను నాకు అర్థం కాలే, అంతగా బ్లాంక్ ప్లేస్ ఇచ్చారా గుడ్ మార్నింగ్ అంటే. రైట్. అప్ టు ఎస్టర్డే వాట్ వి డిడ్? అటామిక్ స్ట్రక్చర్ ఓన్లీ. అటామిక్ స్ట్రక్చర్లో ఎంతవరకు డిస్కస్ చేద్దాం? హైడ్రోజన్ స్పెక్ట్రమ్ we did, right? Now in hydrogen spectrum only they used to ask the wave number for a given spectral line. The wave number for a given spectral line, that is nu bar equal to, nu bar means, as we did, what is that nu bar? That is the reciprocal of wavelength, right? That 1 by lambda equal to r z square. R means Rydberg constant. R z square into 1 by n1 square minus 1 by n2 square. That is n1 is lower energy level, n2 is higher energy level. Okay. Otherwise, if you need to find lambda directly, means wavelength, that how do we write? 1 by r z square into n1 square into n2 square by n2 square minus n1 square. This is formula for lambda. This is formula for 1 by lambda. Okay, don't be confused. Now, if you need to find r value, what is the r value? Rydberg constant value 106977. While coming for 1 by r value, we can take 918 angstroms. In some of the cases, you can take 920 also, no problem. Okay. The next, after the conclusion of Bohr's atomic model, there are again what we have, somewhat demerits. So what are those demerits? The first one is he used one formula, mvr equal to nh by 2 pi. The angular momentum is nh by 2 pi. Why we are going to get that mvr equal to nh by 2 pi? He did not explain. That is the first thing. It is only applicable for hydrogen-like atoms, means the atoms which contains only one electron. Next, another important thing, the hydrogen spectrum could not be explained by Bohr's atomic model. We are going to take, what is that? Zeeman effect and Stark effect. Zeeman effect means, as we discussed already, we are going to find 5 lines: Lyman series, Balmer series, Paschen series, bracket series, P-Fund series. The same spectrum, while we are going to place it in a electric field as well as magnetic field, each spectral line can be dissociated into somewhat discreted lines. That means besides orbits, there are some other thing is there while electron is going to revolve. Electron revolve చేసేటప్పుడు ఆర్బిట్ తో పాటు ఇంకా somewhat ఉన్నాయని చెప్తాడు. ఎవరైనా వాయిస్ లో మెసేజ్ చేశారా? లేదు కదా. So 1 by R is 918 angstroms. The Zeeman effect and Stark effect. Zeeman effect means in presence of magnetic field, what will happen? Each spectral line is going to discreted into many lines. That is not explained by Bohr's atomic model. That is the first thing. The same spectrum, while you are going to place under electric field, that each line is going to discreted into many lines. That is also called, that is called Stark effect. That is called Stark effect. నువ్వు ఎక్కడ కదరా ఏ సెక్షన్ నువ్వు టీయా P2 P2 okay. Each line is going to discreted into many lines that could not be explained by Bohr's atomic model. Okay, got it. Now, so to explain the basic thing, that is why angular momentum of electron, that is in an orbit, is equal to nh by 2 pi. This is going to explained by one more theory, that is called de Broglie's dual nature of matter. What is that? De Broglie's dual nature of matter. So what is that de Broglie's dual nature of matter? The first concept is de Broglie's dual nature of matter. What is dual nature? The simple thing. What is dual nature? If you are going to consider any substance, okay, if you are going to take any substance that has two different types of nature, one is called particle nature and the other one is wave nature. The both natures we are going to find for an object. But when particle nature is going to dominate from the wave nature, when the wave nature is going to dominate. The simple thing, we have two types of substances. Some of the substances are called micro substances, which is said to be microsystem, and some of the substances are said to be macro system or macro substances. The macro means the quantity is large enough. The micro means the quantity is very small, which is almost invisible. Which is almost invisible. So the micro substance nature can have wave nature. The macro can have particle nature. That is the simple thing. The micro substances can have wave nature, and while coming for the macro particles can have particle nature. What kind of nature? Particle nature. Simple thing. When the wave nature is going to dominate, the simple thing, the substance can have large mass, small quantity, means mass is very less. If mass is very less, that can have wave nature. If quantity is more, means mass is more, that can have macro particles, means particle nature. Okay, now how we are going to find out? The simple thing, how he is going to give the relation between mass and wave nature, he used two theories. One is Einstein theory, that is E equal to mc square. E equal to mc square. Okay. And the other one is, this is from Einstein theory, and other one is E equal to h nu from Planck's quantum theory. That h nu equal to, we can write hc by lambda. From these two things, energy is equal to mc square, means velocity, mass into speed of the light, and E equal to hc by lambda. From these two things, how do we write hc by lambda? That is mc square equal to hc by lambda. This c square, c will cancel. Then lambda is going to write as h by m. C is nothing but speed. In terms of speed, we are going to write velocity. What is that? Velocity. That means how we are going to write, if h is constant, the lambda is always inversely proportional to its momentum. That means directly or indirectly we can write lambda is inversely proportional to mass. As mass increases, the wave nature decreases. The wave nature decreases. Right. Okay. Well, coming for the next one. By using this de Broglie's wave nature and wave, we are going to find what is that? Kinetic energy. What do we find? Kinetic energy. But as we wrote already, lambda equal to what is the formula we wrote? H by mv. Let me square on both sides. Then how do we write? Lambda square equal to h square by this we can write as mv square into m. Let me divisor and multiply with 2. Okay. This is 1 by 2 mv square is nothing but kinetic energy. So that you can write lambda square equal to h square by 2 into mass into kinetic energy. Okay. Got it. Then lambda becomes lambda equal to h by root over 2m kinetic energy. As we discussed already, the kinetic energy under potential difference is equal to what is that? Charge into potential difference applied. It's not electron volts. Don't be confused. E represents charge of electron. V represents potential difference that we applied. So what is the charge of electron? 1.602 into 10 power minus 19 coulombs. Okay. Now, so that we can write lambda equal to h by root over 2m EV, where E equal to charge on electron, V equal to potential difference that we applied. ఇక్కడ పెడితే నాకు ఎలా తెలుస్తుందమ్మా? Okay, na? Then after de Broglie's dual nature, we have what is that? Heisenberg uncertainty principle. Heisenberg uncertainty principle. What is that Heisenberg uncertainty principle? Yes. For example, there we have somewhere the electron is there in an atom. Here is the electron. If you need to find the exact position, if you need to find the exact position of an electron, if you need to see an object, what is the basic thing required? Under microscope or under any ultra microscope, anywhere, if you need to find the position of an object, what is the basic thing needed? అరే మనం చూడటానికి ఏం కావాలరా? వెరీ గుడ్ రా, నేను గుడ్డోండు కాదురా స్వామి, నాకు కళ్ళు ఉన్నాయి అనుకోండి. ఇప్పుడు ఏం కావాలి? ఎస్, ద బేసిక్ రిక్వైర్డ్ థింగ్ ఈజ్ లైట్. లైట్ లేకుండా నువ్వు చూడగలవా? కళ్ళు ఉన్నాయి, నైట్ నువ్వు చూడగలవరా? మొత్తం లైట్స్ ఆఫ్ చేస్తే చూడలేం కదా. అంటే ఏం చేయాలా? ఇఫ్ యూ నీడ్ టు సీ ద పొజిషన్ ఆఫ్ ఎగ్జాక్ట్ పొజిషన్ ఆఫ్ ద ఎలక్ట్రాన్, we need to irradiate certain amount of radiation. But what is the demerit we have? The electron can absorb light. As the electron absorbs the light, then what will happen? It can promote it to the higher energy levels, as we discussed yesterday for hydrogen spectrum, right? by giving exactly 13.6 electron volts of energy, what happened? The electron promoted to the higher energy level, promoted to the higher energy level. So if you need to find the exact position of the electron by irradiating some amount of radiation, the position can be changed. The position can be changed. That means if you are going to find the position of an electron, you can get somewhat error. For example, I am giving to find the electron position for this one, for this one, for this one. Different students I gave. Someone is going to reported the distance is 0.79 angstrom, and some other girl can find some 795 angstroms, and some other girl or some other boy is going to reported the value 0.695. There is no equal values. If you are not going to find the exact values, that word is called uncertainty. What is that? Uncertainty. Okay. So if you are going to find the exact uncertainty in position, simultaneously exact uncertainty in momentum, you could not get the exact value. So if you need to make that error, the change in position is called delta x. The change in momentum is called delta p. That must be greater than or equal to h by 4 pi. h by 4 pi. మీరు అక్కడ అయిపోయారు MVR equal to NH by 2 pi దగ్గర. That's not NH by 2 pi. That is h by 4 pi. Actually, in previous books, previous contents, that is actually there with h by 2 pi, but that has been modified. h by 4 pi. Okay. So if there is no change in position, if delta x equal to 0, if delta x equal to 0, then delta p becomes what it becomes? Delta p greater than or equal to h by 4 pi. This x into delta x means 0, we are going to substitute. That anything by 0 becomes, anything by 0 becomes, that becomes infinity. That becomes infinity. That means if there is no change in position of, what is that? Electron. If you need to find the change in position of momentum, that becomes infinity. In the same way, if delta p equal to 0, then delta x becomes, then what will happen? Then delta x becomes infinity. That means there must be somewhat uncertainty in change in position as well as change in momentum. Okay, the momentum we are going to substitute the value that we are going to write delta x into m into change in velocity is greater than or equal to h by 4 pi. And remember one more thing, if you need to find delta v, that you can write velocity of electron into percentage of accuracy. What is that question lo? By percentage means 100. దీంతో మల్టిప్లై చేస్తేనే so that you are going to find delta v value. Right up. Okay. So the atomic models have been done. Okay. The next third concept we gave, what is that? 3 parts we gave, right? The first part, second part done. While coming for the third part, what is the third part? Yes, quantum numbers. What are quantum numbers? What is the meaning of quantum numbers? Can anyone? What are the meaning of quantum numbers? Quantum numbers and endma. For example, I am going to take nitrogen atom. What I am taking? Nitrogen atom. What is the atomic number of nitrogen atom? 7. If I need to write electronic configuration, how do I am going to write 1s2, 2s2? This is 2p3. 2p3. Now, I need to find the properties of 7th electron. What I need to find? The properties of 7th electron. The properties means the position. Position means in which orbital it has, in which orbit it has. Okay, as well as energy. If I need to find exactly, I need to represent, I need to use some numbers called quantum numbers. What are those? Quantum numbers. So quantum numbers basic use is, we are going to find the exact position of electron where it is located in a given atom, as well as its energy can be found with the help of quantum numbers. Okay, so how many quantum numbers we have actually? How many quantum numbers we have? We have, as you learn already in first year, one of the most important IPE question. What is that? Principal quantum number, azimuthal quantum number, magnetic quantum number, spin quantum number. Okay. So first coming for that, principal quantum number. I am not going to write it is proposed by Bohr. It is denoted with n. Okay. I am not going to write that one. The simple thing is, what is the use of the n? That is principal quantum number. The simple logic, the principal quantum number represents the orbits. Don't be confused. N is going to represent the orbits. That means, if you are going to take an orbit, the orbit contains subcells, as we discussed already to explain Zeeman effect and Stark effect. Because if you are going to take a hydrogen atom that contains only one electron, where it is located? Where it is located? If I am taking hydrogen atom, the hydrogen atom electronic configuration, atomic number 1, electronic configuration, we are going to write 1s1. What we are going to write? 1s1. That means the electron is located at only K shell. There are no electrons in L shell, M shell, whatever the cell we have. The electron is only located in K shell. That is the first shell. So that is the reason even L contains, don't be confused. See, K contains only one cell. This is orbit. This is subshell. Okay. The K shell contains only one subshell, that is S. L shell contains two subshells, S and P. Okay. M shell contains three subshells, S, P, D. And N contains four subshells, S, P, D, F. If you take O, that contains S, P, D, F, G. Like that we can write. So that is the reason, if you are going to place the spectrum under magnetic field or electric field, K shell can give only one line because it cannot be discreted, because it contains only one subshell. While coming for the L contains two subshells, is going to give how many lines it is going to propose? S plus P means 4 cells. 4 lines it is going to propose, because the subshell still contains another word called orbitals. Don't be confused. The orbit contains subshell. The subshell contains orbitals. Okay, now the S orbital contains only one. S contains 1, P contains 3. 1 plus 3, 4. S contains 1, P contains 3, D contains 5. So total 9. S contains 1, P contains 3, D contains 5, F contains 7. So total 16. Like that we are going to write. Okay. Always an orbit contains subshell. The subshell contains which one? Orbital. So if you are going to take this one represented by principal quantum number, and this one represented by azimuthal quantum number, and this one represented by which one? magnetic quantum number. Simple logic. Okay, spin is going to represent the spin of electron in a given atom. Okay, now, so by using n, what we are going to propose, it is going to give only orbits. The n can have the values 1, 2, 3, 4 as per k, l, m, n, like that. For k you can take 1, for l you can take 2, for m you can take 3. Okay. Now, by using n, what we are going to find? Number of subcells if you need to find, that equal to n. Number of orbitals you are going to find, number of orbitals. That is how many orbitals it has? N square. Don't be confused. For k, n equal to 1. N equal to 1. Subcells 1. Got it? Subcells 1. Orbitals n square. 1 square means 1 only. Here, for L, n equal to 2. Number of subcells 2. SUP. Number of orbitals 2 square means 4. Got it? If you need to find number of electrons in a given orbit, that equal to 2n square. What is that? 2n square. Not even this one. Even we are going to find the angular momentum of an electron present in an orbit, not orbital. The angular momentum present an electron in an orbit, that we are going to write mvr equal to nh by 2 pi. nh by 2 pi. This we are going to write. This is the use of principal quantum number. While coming for the azimuthal quantum number, what it represents? What it represents, azimuthal quantum number? Representing subcell. Representing subcell. Don't be confused. So L can have the values started from 0, 1, 2, so up to ending with n minus 1. The maximum value of an L for an atom is nothing but n minus 1. n minus 1. The L values are constant for given subcells. For S you can write 0. For P you can write 1. For D you can write 2. Sorry. For F you can write 3. Write down. Yeah, good, Nitya Ashni. మా ఆన్లైన్ స్టూడెంట్స్ మీకు ఏదైనా ప్రాబ్లం ఉంటే చాట్ చేయండి అమ్మా. If you are not getting anywhere, just to text me through the app. Okay, now by using L, what we are going to find? Number of orbitals if you need to find. What is the formula? 2L plus 1. If you need to find number of electrons in a given orbit, this is orbitals, that you can write 2 into 2L plus 1. How many number of maximum electrons that can be accommodated in an orbital? ఎన్ని అకామిడేట్ చేయగల maximum number 2. Okay na? How many number of electrons accommodated in p orbital? Very good. అట్లనే చెప్తారు 6 అని. కానీ ఆన్సర్ ఏంటంటే 2. ఇక్కడ క్లియర్ గా మెన్షన్ చేశాను నేను వర్డ్. ఆర్బిట్ ఈజ్ డిఫరెంట్ ఫ్రమ్ సబ్సెల్ ఈజ్ డిఫరెంట్ ఫ్రమ్ ఆర్బిటాల్. If I am going to ask the maximum number of electrons that can be accommodated in p subcell, you can say 6, no problem. P orbital. Orbital means the maximum number of electrons that can be accommodated in any orbital, that is only 2. The maximum number of electrons that can be accommodated in d orbital, f orbital, s orbital, any orbital, you can take only 2 electrons. In case of if we mentioned subcell, then you can write the maximum number of orbitals into 2. For example, p subcell, 2 into 3, 6, because 3 orbitals are there in p subcell. For d, 2 into 5, 10. For s, 2 into 1, 2. Got it? For f, 2 into 7 orbitals, 14 electrons. Like that only we can answer. Okay. Now, if you need to find angular momentum of an electron in a given subcell or orbital, anything you can have, subcell or orbital, that you can write root over L into L plus 1, okay, into h by 2 pi. There is no root for h by 2 pi. Don't be confused. Only root for L into L plus 1. Online students, is my voice is audible? Nitya, check it once. Okay. If someone is not getting my voice, the only reason is there are some issues with your network. Okay. Yeah. Right. Next one. By using this particular azimuthal quantum number only, we are going to find different things. Not even this one. We can find one more word, that is called, by using L only, means azimuthal quantum number only, we are going to find 2 more things, that is called the word said to be orbital, and the other one is node. The orbitals or nodes are going to find with the help of one more concept, that is called Schrödinger wave equation. What is that? Schrödinger wave equation. Sir, what is that use of Schrödinger wave equation? The simple thing, as we discussed, what is that? If you are going to take a macro particle that can have particle nature, the particle nature of any substance can be explained with the help of classical mechanics. What is that? Classical mechanics. Classical mechanics means, if you are going to take potential energy, what is the formula you are going to write? P, potential energy. With respect to gravitation, you can write mgh. Okay, got it? If you need to write kinetic energy, you are going to write half into mv square. So whatever the formulas we are going to use, or whatever the concept we are going to use to explain that kind of formulas, that is called classical mechanics. Don't be confused. The classical mechanics is only useful for to explain the nature of which one? macro particles, the quantity must be more. If you take a micro particle, the micro particle nature cannot be explained with the help of classical mechanics. We are not going to use the formulas directly from the classical mechanics. So to explain the micro particle nature, we are going to use quantum mechanics. What is that? Quantum mechanics. Quantum mechanics means, quantum means, what is quantum? Is nothing but light. Quantum is nothing but light. So whatever the formulas we have with respect to wave nature of the light, that is lambda. Got it? By using lambda, we are going to find, what is that? Microparticles nature. So to explain a microparticle nature like wave nature, the electrons, protons, neutrons, whatever we have, those are all microparticles because their mass is very less. So to explain the nature of electron, we are going to use Schrödinger wave equation. What is that Schrödinger wave equation? We are not going to take complete derivation. Dou indicates that partial derivation. Dou square psi by dou x square plus dou square psi by dou y square plus dou square psi by dou z square plus 8 pi square m by 8 pi square m by h square into e minus v into psi equal to 0. ఇక్కడ ఉండే వర్డ్స్ ఏంటనేసి అంటే one is psi square, don't be confused, and the other one is psi. సార్ మీరు అన్ని దగ్గరలో psi రాసి ఎక్కడ psi square ఎక్కడ ఉందని మీకు డౌట్ వస్తుంది, అంతేనా? అంతే కదరా? This is also psi, this is also psi, this is also psi, this is also psi. Where is psi square? And doubt వస్తుంది. This is actually psi square. Don't be confused. If you are going to write sin theta square, sin square theta, what it indicates? ఈ రెండిట్లో ఎట్లా రాస్తా ఉంటారు మీరు మ్యాథమెటిక్స్ లో? sin square theta అని రాస్తారు. This is called operator. What is this? Operator. This is called actually function or property. అర్థమవుతుందా? సో ఎప్పుడైనా మనం ఒక ఫంక్షన్ ని మనం ఏదైనా స్క్వేర్ చేయాలన్నా క్యూబ్ చేయాలనేసి అన్నా, వైల్ వీఆర్ గోయింగ్ టు రిప్రజెంట్ విత్ అన్ ఆపరేటర్, వి నీడ్ టు గివ్ దట్ ఫంక్షన్ టువర్డ్స్ ద ఆపరేటర్. నువ్వు ఏ ఫంక్షన్ అయితే చేయాలనుకుంటావో ఆ ఫంక్షన్ ఆపరేటర్కి ఇవ్వాలి. హియర్ డో స్క్వేర్ psi indicates that not representing, what is that? డో, it representing psi square. ఇక్కడే psi square ఉందని అర్థం. ఓకేనా? So we have the word psi square and psi. Psi indicates wave function. What is that? Wave function. Psi square indicates that probability function. What is that? Probability function. As you know that H is Planck's constant, E is nothing but total energy. Don't be confused. Total energy. V is nothing but potential energy. Malli velocity anukuntaru babu. Velocity kaadu, potential energy. E is total energy, V is potential energy. Remaining all words you can have, very familiar. M means mass. Okay na? These words ఉంటాయి. That means if the electron is going to considered as a microparticle, the nature, while applying quantum mechanics, that entire thing is going to give 0. అవన్నీ సబ్స్టిట్యూట్ చేస్తే మనకు 0 వస్తుంది. ఓకేనా? ఇక్కడ మనం ఒక వర్డ్ యూజ్ చేస్తున్నాం, ఏంటది? ప్రాబబిలిటీ ఫంక్షన్. వాట్ ఈస్ దిస్? ప్రాబబిలిటీ ఫంక్షన్. వినరా? ఇఫ్ psi square is maximum, ప్రాబబిలిటీ ఫంక్షన్ maximum ఉందనుకోండి. ప్రాబబిలిటీ ఫంక్షన్ అంటే ఏం కాదు. ఫర్ ఎగ్జాంపుల్, నేను న్యూక్లియస్, మీరంతా స్టూడెంట్స్ కదా. మీరు నా రీజియన్లో అంటే నేను నా జోన్లో ఎంతవరకు నేను కాన్సన్ట్రేట్ చేస్తానో దాన్నే ప్రాబబిలిటీ అంటాం. ఫర్ ఎగ్జాంపుల్, ఇందులో మనం గట్టిగా అరవమంటారు కదా, మై వాయిస్ కెన్ రీచ్ అప్ టు సమ్ వాట్ నెంబర్స్, he can receive more volume. The student who sat behind to the entire class లో last లో విన్నోడికి అంతగా రీచ్ అవుతుంది. That is called probability. In the same way, if the electron is there at somewhere from the there in the atom, somewhere from the nucleus, ఎక్కడో ఒక ఎలక్ట్రాన్ ఉంది. ఎలక్ట్రాన్ ఉండేటప్పుడు దిస్ ఎలక్ట్రాన్ ఈజ్ గోయింగ్ టు రివాల్వ్ అరౌండ్ ద న్యూక్లియస్. మీరేమనుకుంటారు, ఇది న్యూక్లియస్ కాబట్టి ఈ ఎలక్ట్రాన్ ఎట్లా తిరిగేస్తూ ఉంటుంది అనేసి అనుకుంటాను కదా. అట్లా ఒరిజినల్గా అట్లా ఏం తిరిగేది, అర్థమవుతుందా? దిస్ ఈజ్ గోయింగ్ టు రొటేట్ ఇన్ ఇట్స్ ఓన్ యాక్సిస్. దాని ఓన్ యాక్సిస్లో ఎలా తిరుగుతూ ఉంటుంది. ఓకేనా? Within that own axis as well as it is going to revolve around the nucleus, how it is going to there in a particular orbital. అర్థమవుతుందా? అంటే దిస్ ఈజ్ ద న్యూక్లియస్. హియర్ ఐ ఆమ్ గోయింగ్ టు లేబుల్ ద ప్రాబబిలిటీ రీజియన్. నేను ఒక ప్రాబబిలిటీ రీజియన్ని మొత్తాన్ని లేబుల్ చేసుకుంటున్నా. ఈ రీజియన్లో నాకు ఎలక్ట్రాన్ కనిపిస్తుంది. ఎవరి వల్ల? దిస్ ఎలక్ట్రాన్ ఈజ్ దేర్ అండర్ ఇన్ఫ్లుయెన్స్ ఆఫ్ న్యూక్లియస్. ఓకే, this is the maximum probability region where the electron can be found by the nucleus. This particular portion is called orbital. What is this? Orbital. The orbital is the space actually. That space at which the electron can be found by the nucleus, probability must be maximum. What is that? Probability must be maximum. If you are going to label this entire part, what I got? Like a, what kind of shape it has? Like a spherical or sphere. This spherical shape or sphere is said to be s orbital. Otherwise, somewhere the electron is going to find like this. Okay, that is called dumbbell shape, said to be t orbital. What is that? T orbital. If you are going to find double dumbbell, yes, double dumbbell represents d orbital. Somewhat rigidity or quadruple dumbbell represents f orbital. Somewhat complexity is there. కొంచెం కాంప్లెక్సిటీ ఉంటుంది ఎఫ్ ఆర్బిటల్. ఓకేనా? అర్థమైందా? ఇలా సై స్క్వేర్ మ్యాక్సిమం అయితే దట్ రీజియన్ ఈజ్ కాల్డ్ ఆర్బిటాల్. వాట్ ఈస్ దట్? ఆర్బిటాల్. ఇన్ కేస్ ఆఫ్ సై స్క్వేర్ ఈజ్ 0, అంటే ఇక్కడ నుండి ఇక్కడ ఎలక్ట్రాన్ ఉంది అంతేనా? బట్ వాట్ ఈస్ దిస్ ఎంటైర్ పార్ట్? ఇక్కడ ఏమైనా ఎలక్ట్రాన్ ఉందా? లేదు. అంటే ఏమవుతుంది? ద సై స్క్వేర్ బికమ్స్ 0. ఇన్ కేస్ ఆఫ్ ద సై స్క్వేర్ ఈజ్ 0, దట్ కైండ్ ఆఫ్ పార్ట్ ఈజ్ కాల్డ్ నోడ్. వాట్ కెన్ వి సే? నోడ్. రైట్. So how many types of nodes we have? Can anyone? How many types nodes we have? 2 types of nodes actually. One is called radial node, don't be confused, or spherical node. Both words are identical only. Radial also called spherical. Got it? While coming for this one, this is called angular node, or we can say nodal plane. What is that? Nodal plane. So what is the difference between these two? ఒకసారి జాగ్రత్తగా చూడండి, కన్ఫ్యూజ్ అవ్వద్దు. రేడియల్ ఆర్ స్పెరికల్ నోడ్ అంటే ఏంటంటే, దిస్ ఈజ్ ద న్యూక్లియస్ ఐ హ్యావ్. హియర్ ఈజ్ మై ఫస్ట్ ఆర్బిట్ K. దిస్ ఈజ్ సెకండ్ ఆర్బిట్ L. హియర్ సమ్ ఆర్బిటాల్స్ ఆర్ దేర్. S orbital, here S orbital and P orbital. Now, if I am going to observe within the between K and L, between K and L, do we find any electron over here? This is, if you are going to label this entire part, this is also like a sphere, like a sphere, like a ball, at which psi square is 0. Psi square is 0. But psi square is 0. So this kind of node is called spherical node or radial node. For K shell, how many spherical nodes we have? 0, because this is the first ever orbit. While K to L, how many spherical nodes we have? 1 spherical node. If we are coming from L to M, how many spherical nodes? This one and this one. Got it? That is called spherical node or radial node. Don't be confused. This is K cell radius we gave. Rn equal to, what is the formula we gave? 0.53 n square by z angstroms. Got it? So the K cell is located 0.53 angstroms. L becomes 0.53 into 4. 4 3 is 12, 4 5 is 20. That is 2.12 angstroms. L cell is located at 2.12 angstroms. M cell is located into 9. 9 3 is 27, 9 5 is 45. 4.77 angstroms. This is K, 0.53. This is L located. This is M located. Okay now. For K, 0 spherical nodes. For L, 1 spherical node. For M, 2 spherical nodes. For N, 3 spherical nodes. Got it? Right. మా ఇక్కడ మీ క్లాస్లో మనం సూక్ష్మంలో మోక్షం అంటే ఎప్పుడైనా తెలుసా? సూక్ష్మంలో మోక్షం అనేది జనరల్గా హిందూ కల్చర్ ప్రకారం ఏం చేస్తారనేసి అంటే, నువ్వు ఏదైనా ఒక పుణ్య కార్యక్రమం చేయాలనేసి అంటే యూ నీడ్ టు విజిట్ టెంపుల్స్. టెంపుల్స్ అనేసి అంటే అవి ఎక్కడ అన్ని దగ్గరలో ఉంటాయండి టెంపుల్స్. జనరల్గా మన బాగా ప్రీవియస్ డేస్లో అయితే కొన్ని లొకేషన్స్లోనే ఉండేవి. కాశీ అని, తిరుమల తిరుపతి అని అట్లా ఉండేది. అంటే అక్కడికి వెళ్ళి నువ్వు ఏదైనా ఒక పుణ్య కార్యక్రమం చేస్తే, ఒక మంచిగా పూజ చేస్తే నీకు పుణ్యం దక్కేదంట. ఓకేనా? అదేంది లెంగ్తీ ప్రాసెస్. సూక్ష్మంలో మోక్షం అంటే ఏంటనేసి అంటే అక్కడికి వెళ్తే నీకు మోక్షం వచ్చినట్టు. మోక్షం అనేసి అంటే నువ్వు చేసిన పాప కార్యక్రమాలన్నీ అక్కడితో తొలగిపోయినాయి. మళ్ళీ నువ్వు ఫ్రెష్, మళ్ళీ పుట్టినట్టే. ఇంకా అక్కడి నుంచి నువ్వు ఎన్ని దరిద్రాలైనా చేసుకోవచ్చు. అట్లా నమ్మేవాళ్ళు. సో అంత దూరం వెళ్ళడం కోసం కష్టమని ఇప్పుడు ఏం చేసేవాళ్ళు, అంత దూరం మనం ఎందుకు పోవడం అనేసి హ్యాపీగా ప్రతి ఒక్కడు ఊళ్ళో కూడా ఒక చిన్న టెంపుల్స్ కట్టుకోవడం మొదలుపెట్టారు. అర్థమైందా? అక్కడికి వెళ్ళే బదులు ఇక్కడికి వెళ్తే అయిపోయేది. మొత్తం నీకు వచ్చేసింది, ఈ పాపాలన్నీ పోయాయి. దాన్నే సూక్ష్మంలో మోక్షం అంటారు. అంటే పెద్ద లెంగ్తీ ప్రాసెస్ ఏం లేదు. ఇక్కడ కూడా మనం చేసేది అదే. సూక్ష్మంలో మోక్షం అంటే ఏంటంటే నేను చెప్పే కంటెంట్ చాలా తక్కువ. కంటెంట్ తక్కువ అనేసి అంటే అర్థం ఏంది? మొత్తాన్ని మిక్సీలో వేసి ఒక 4 సంవత్సరాలు 5 సంవత్సరాలు బాగా మిక్సీ చేస్తే లాస్ట్లో వస్తుంది కదా రెసిడ్యువల్ కాంపోనెంట్. అలాంటిది అనమాట. ఇది కూడా చదవడానికి కొంతమంది లేజీగా ఉంటారు, చెప్తారులే అనేసి. దయచేసి అట్లా చేయొద్దు. అట్లీస్ట్ ఇదైనా మీరు కాన్సన్ట్రేట్ చేసి రెగ్యులర్గా చదువుకుంటే 4 క్వశ్చన్లు చేస్తారు. ఓకేనా? 4 క్వశ్చన్లు కాదు, నీకు వచ్చే ప్రతి క్వశ్చన్ మనం కవర్ చేసే దానిలోనే ఉంటుంది. ఫైనల్గా నువ్వు ఈ 45 రోజులైనా కంప్లీట్ నువ్వు ఎఫర్ట్ పెడితే అన్ని క్వశ్చన్లు ఆన్సర్ చేస్తావు, చక్కగా 4 మార్కులు వస్తాయి. ఓకేనా? వాళ్ళు ఇచ్చే ప్రాక్టీస్ సెషన్లో దయచేసి టైం వేస్ట్ చేయొద్దు. ఓకేనా? రైట్. నెక్స్ట్ వన్. దీనికి గ్రాఫికల్ రిప్రజెంట్స్ ఇచ్చేటప్పుడు చూడండి. దిస్ ఈజ్ కాల్డ్ రేడియల్ ప్రాబబిలిటీ ఫంక్షన్. సై స్క్వేర్ అనేసి అంటాడు. రేడియల్ ప్రాబబిలిటీ ఫంక్షన్. హీ ఈస్ గోయింగ్ టు డినోట్స్ విత్ డిస్టెన్స్, మీన్స్ రేడియస్ ఆఫ్ nth ఆర్బిట్. రేడియస్ అబ్జర్వ్ చేస్తాడు స్పెరికల్ నోట్స్ అనేటప్పుడు. దీనికి ఆల్రెడీ మనం చెప్పాం. కే ఈజ్ లొకేటెడ్ వేర్? from the distance nucleus, where it is located? 0.53 angstroms. L located at 2.12 angstroms. Don't be confused. M located 77 angstroms. This is the simple thing. Okay. Now, the K contains how many cells? K contains one cell, yes. L contains S and P. M contains S, P, D. The simple thing, S orbitals have been started from K. That means N equal to 1. So that is the reason we are going to write 1s2, 2s2 like that we are going to write. We are not going to write 1p. ఎక్కడైనా ఉందా? ఎప్పుడైనా చూసారా 1p అనేది? 2d అనేది ఎక్కడైనా చూసారా? 3f అనేది ఎక్కడైనా చూసారా? చూసారా? ఉండవు. ఎందుకని అంటే because those particular subcells are not starting from that particular shell called orbit. ఆ orbits దగ్గర start అవ్వు. ఓకేనా? So S is started from K, so we can write 1s. P is going to started with L, so that N value is 2, 2s, 2p. M is, that means D is started from M, that is 3s, 3p, 3d. Like that only we are going to write. Atla raskunta. 3s, 3p, 3d. Okay. Now, if I am taking psi square, this is 0.53 angstroms, which is taken on radius on x coordinate, psi square probability function on y coordinate. If I am going to get only one peak at the distance of 0.53 angstroms, now which orbital it is? అని అడిగితే ఏ ఆర్బిటల్? ఎక్కడ పీక్ ఉంది? ఒకే ఒక పీక్ ఉంది. ఎక్కడ ఉంది? ఓకేనా? సో దిస్ రిప్రజెంట్స్ 1s orbital. What is that? 1s orbital. అర్థమవుతుందా? Now, this is psi square. This is radius of nth orbit. I am getting, this is first peak, this is second peak. This second peak I observed at 2.12 angstroms. So now which orbital it is? Which orbital it is? 2p. Very good. చూసుకోండి. Spherical nodes formula ఏంటంటే the number of spherical nodes are radial nodes. That is n minus L minus 1. N minus L minus 1. If it is 2p orbital, నువ్వు 2p orbital తీసుకున్నావు అనుకో, 2p orbital లో n value 2, L value 1, 2 minus 1 minus 1, 0. Do we find any spherical node? Spherical node ఏమైనా ఉంటుందా? కానీ దీనిలో ఏముంది spherical node? We have one spherical node here. Psi square is, what is psi square here? 0. That is called spherical node. The spherical node is 1 for at the distance 2.12. Which orbital? If you take 2s orbital, what is the formula? 2 minus 0 minus 1. How many spherical nodes we have? One spherical node that is there here. So this represents which orbital? 2s orbital. Don't be confused. Got it? Another simple thing, I am getting two peaks at the distance 2.12. Before one peak, I have already one more peak. That means one orbital already there. Before that, another orbital is there. Before 2s and 2p, do we find which orbital? 1s orbital. If you are going to find at the distance of 2.1 to 2 peaks, that indicates 2s orbital. The same thing if I am going to draw like this. This is psi square only. This is radius only. 2.12 angstroms I am giving. Radius only. Now, if I am going to draw only one peak, now this becomes which p orbital? 2p orbital. What is this? 2p orbital. Because for 2p orbitals, radial nodes are 0. Radial nodes are 0. The same way, if you have psi square, this is 1, 2, this is, I am going to write 3. This is distance 4.77 angstroms. Now this particular graph is representing which orbital? This is the peak at the third orbit, right? Before that, how many peaks we have? 2 peaks. This is, if we are going to consider 3D, we don't have 2D, right? So it does not represent 3D. 3D represents cheyadu. Okay na? While coming for 3P, 3P kellam. If it is 3P, the next one is 2P. The next one is 1P. Do we have 1P? No. Then what it becomes? 3s, because 3s, 2s, 1s. Got it? For 3s, how many radial nodes? N minus L minus 1. 3 minus 0 minus 1. 3 minus 1 equal to 2 nodes. This is one spherical node and this is one spherical node. Got it? If the same distance like 4.77 only we have, psi square 4.77 only angstroms. If you are going to find like this, which orbital it becomes? 3p. The same psi square and what is the distance we are taking? Same 4.77 angstroms. Okay, if you are going to get only one peak, that represents 3D. Are you clear with this? Everyone, write down. Okay. అమ్మా నువ్వేం చేస్తున్నావు అంటే నార్మల్ హిల్ వేస్తున్నావు. మనం వేయాల్సింది ఎవరెస్ట్ మౌంటైన్. ఓకేనా? ఇలా పైకి రావాలా. చిన్నప్పుడు క్యామెల్ డయాగ్రామ్ ప్రాక్టీస్ చేయలే, డ్రా చేయలేదా? ఓయ్ next one. These are radial nodes or spherical nodes. You got clarity, right? Right. Next one. Okay. Nodal plane are also called. Nodal plane, angular node. So this angular node or nodal plane depends on the shape of orbital. Then may depend on the shape of orbital pine depend. What is that? Shape of orbital. For example, if you take S orbital, what is the shape of S orbital? It's like a sphere. That means all the three coordinates placed over this sphere because it is symmetrical. And ball compare cheyandra, ball మీద నువ్వేం చేయొచ్చు, డ్రా చేయొచ్చు, x కోఆర్డినేట్ డ్రా చేయొచ్చు, y కోఆర్డినేట్ డ్రా చేయొచ్చు, z కోఆర్డినేట్ డ్రా చేయొచ్చు. That means the psi square is maximum in all coordinates. అన్ని కోఆర్డినేట్స్ లో కూడా psi square అనేది maximum ఉంటుంది. So that is the reason there is no psi square as 0 for any plane. నువ్వు ఏ ప్లేన్ కట్ చేసినా, క్రాస్ చేసినా, you could not find as psi square 0. కాబట్టి ఏమైంది? Number of nodal planes for S orbital, ఎన్ని ఉంటాయి nodal planes? 0. ఏముండవు. Okay. While coming for the p orbital, what is the shape of p orbital? ఏ షేప్ ఉంటుంది p orbital కి? డంబెల్ షేప్. సో డంబెల్ షేప్ ఉందనుకున్నాను, చూడండి జాగ్రత్తగా. ఫర్ ఎగ్జాంపుల్ ఐఎమ్ టేకింగ్ px కోఆర్డినేట్ తీసుకుంటే px orbital, ఐఎమ్ గోయింగ్ టు రైట్ ద lobes. along the x coordinate. A coordinate lo rasa, x coordinate lo rasa. If you are going to place one plane along y and z coordinates, ఇది y coordinate, ఇది z coordinate అనుకుంటే, I can find this is the plane at which psi square is 0. Psi square is 0. So yz plane, what happened? The psi square becomes 0, said to be nodal. That is called nodal plane. What is that? Nodal plane. So for p orbitals, how many number of nodal planes we have? 1. Don't be confused. For px you can find yz plane. For py you can take xz plane. For pz you can take xy plane. Don't be confused. Okay. Now, if you take d orbital తీసుకుంటే ఏంటి షేప్ డబుల్ డంబెల్ కాబట్టి ఎన్ని ఉంటాయని అంటే చూడండి, ఇది ఫర్ ఎగ్జాంపుల్ యూ కెన్ టేక్ లైక్ దిస్ ఈజ్ డబుల్ డంబెల్. ఓకే, సో దిస్ ఈజ్ వన్ ప్లేన్ and this is another plane. To make psi square is 0. To make psi square is 0. So how many nodal planes we have? 2 nodal planes. గుర్తుపెట్టుకోండి. For dxy orbital ఎన్ని nodal planes ఉంటాయి? That is yz and zx. Okay, whereas dyz సేమ్ ఎట్లా రాసుకోండి, ఈ రెండు తీసేసి మిగిలిన కాంబినేషన్ రాసుకోండి, xy zx. dzx yz xy, same thing. dx square minus y square, dx square minus y square, same thing like dxy, yz and zx planes. dz square, dz square, ఏమొద్దమ్మా, నోడల్ ప్లేన్స్ ఆర్ 0. నోడల్ ప్లేన్స్ ఉండవు దీనికి, 0. Instead of nodal planes, what we have? We have nodal cones. ఏముంటాయి? Nodal cones ఉంటాయి. How many nodal cones we have? 2. Because the shape of the dz square is like this. Now this is one nodal cone and this is another nodal cone. Got it? Only for dz square orbital the number of nodal planes are 0. Instead of nodal planes, what we have? Nodal cones we have. Whereas the remaining all d orbitals can have nodal planes, that is 2. Okay na? ఈ dx square minus y square shape మాత్రమే different ఉంటుంది. The lobes are lying along the x and y coordinate. Whereas these 3 remaining can have the same shapes, that is the lobes are lying in between the axis. So the simple thing we can write for s orbital, p orbital, d orbital, f orbital, number of nodal planes 0, 1, 2, 3, so on n minus 1. This is nothing but L, means azimuthal quantum number. So number of nodal planes equal to, you can simply write as L. So from all these content, what can we write? Angular nodes are nodal planes equal to how many? L. Spherical nodes are radial nodes. How many we have? We gave the formula, n minus L minus 1. So total number of nodes, how many we have? n minus L minus 1 plus 1 plus L, that becomes n minus 1. We can write finally. Okay. Completed? Right. The next one, magnetic quantum number. అరే మీరు ఏదైనా కొంచెం మిగిలిపోతే ఏం ప్రాబ్లం లేదు, వీళ్ళు మళ్ళీ పీడిఎఫ్ చేసి పంపిస్తారు గ్రూప్లో, చెక్ చేసుకోండి. ఓకే. Magnetic quantum number. What is the use of magnetic quantum number? Orientations of electrons in a given subcell is nothing but representing orbitals. Then represent chestadi orbitals in represent chestadi. How many values for a given m? M ki enni values untayani ante 2l plus 1. Those are minus l2 plus l. Minus l2 plus l. If you are going to take s orbital, the l value is 0, m value also 0. Contains only one value. Okay. If you take p orbital, l value 1, 2 into 1 plus 1, 3 we have. The 3 are minus 1, 0, plus 1. The 0 stands for pz orbital. Don't be confused. 0 stands for pz orbital. While coming for d subcell, we have l value 2, m value 5. That is minus 2, minus 1, 0, plus 1, plus 2. You can remember 0 stands for dz square orbitals. Okay. And finally, what we have? Spin quantum number. What is spin quantum number? Denotes with S. చూడండి జాగ్రత్తగానండి. మీరు స్పిన్ అంటే ఏమనుకుంటారు? ఫర్ క్లాక్ వైజ్, యాంటీ క్లాక్ వైజ్, ఇది నేర్చుకుంటారు. ఏందో యాంటీ క్లాక్ వైజ్, క్లాక్ వైజ్, మీరేమనుకుంటారు చెప్పండి? ఏంది? +1/2 represents clockwise. ఏ రొటేషన్? ఇది న్యూక్లియస్. మీరేమనుకుంటారు అనేసి అంటే the electron revolving around the nucleus in clockwise can considered as +1/2. Anti-clockwise is called -1/2. అది కాదు. What is that? The electron is going to make revolutions around the nucleus. Simultaneously it makes revolutions, self rotations. అర్థమవుతుందా? సెల్ఫ్ రొటేషన్స్ తీసుకుంటా అంటే దిస్ ఈజ్ ద ఎలక్ట్రాన్ అనుకుంటే, దిస్ ఈజ్ ద ఓన్ యాక్సిస్. ఇట్ ఈస్ గోయింగ్ టు మేక్ రెవల్యూషన్స్ అరౌండ్ ఇట్స్ ఓన్ యాక్సిస్. ఈ ఓన్ యాక్సిస్ లో కూడా రివాల్వ్ అవుతూ ఉంటుంది. ఇఫ్ ఇట్ ఈస్ గోయింగ్ టు రివాల్వ్ అరౌండ్ ఇట్స్ ఓన్ యాక్సిస్ ఎయిదర్ క్లాక్ వైజ్ డైరెక్షన్ లో ఉందనుకోండి, దట్ ఈస్ గోయింగ్ టు కన్సిడర్ యాజ్ +1/2. ఫర్ యాంటీ క్లాక్ వైజ్ వీఆర్ గోయింగ్ టు రైట్ -1/2. అంటే ఎప్పుడైనా ఒక ఆర్బిటాల్లో it is going to, one electron must be revolves around its own axis, one must be clockwise and one must be anti-clockwise. అర్థమవుతుందా? ఒకటి క్లాక్ వైజ్ లో రొటేట్ చేస్తే ఇంకోటి ఖచ్చితంగా యాంటీ క్లాక్ వైజ్ లో రొటేట్ చేస్తుంది. అందుకే మీకు లేబుల్ చేసేటప్పుడు ఇలా ఆర్బిటాల్ రాసేటప్పుడు మీరు జాగ్రత్తగా అబ్జర్వ్ చేసి ఉంటారు. ఒకటి అప్వర్డ్ యారో రాస్తారు, ఒకటి డౌన్వర్డ్ యారో రాస్తారు. దిస్ అప్వర్డ్ యారో ఇండికేటింగ్ దట్ క్లాక్ వైజ్, the downward arrow indicating that anti-clockwise. It doesn't mean the rotation around the nucleus. It means what is that? The self-rotation of electron under it in its own axis. In its own axis. Okay na? అది ఇవి రాసేస్తే ఇంకా క్వశ్చన్స్కి వెళ్ళిపోదాం. ఇంకోటి ఉంటాయి ఏంటది? ఆఫ్ బౌస్ ప్రిన్సిపల్, పౌలీస్ ఎక్స్క్లూజివ్ ప్రిన్సిపల్ తెలుసు కదా, అండ్ హున్స్ రూల్. ఏంటది? ఆఫ్ బౌస్ ప్రిన్సిపల్, ఎనర్జీ ఆఫ్ ఆర్బిటాల్స్. వాట్ ఈస్ ద బేసిక్? n plus l value. If n plus l value is least, that can have less energy. If n plus l value is more, energy is more. చూడండి, మళ్ళీ చెప్పలేదు అనుకుంటారు. చూడండి, ఆఫ్ బౌస్ ప్రిన్సిపల్, దట్ ఈజ్ ఎనర్జీ ఆఫ్ an orbital directly proportional to n plus l. In case of n plus l equal అయ్యాయి అనుకోండి, then energy is directly proportional to n. Two conditions. Okay. E total nodes is n minus 1. Total number of nodes n minus 1, not L. Nitya. L is total number of nodal planes. Okay. Right. Now we will go through questions. The photoelectric effect. The kinetic energy of an emitted electron is given when the radiation of frequency hits the metal. What is the threshold frequency is asking. I am going to give the formulas so that you can solve them. No problem with that. I am not going to write the calculation. Calculation part you can do. Okay. All right. First one. Photoelectric effect. What is the thing we gave? E equal to E naught plus Ke, kinetic energy. He gave the kinetic energy. This is kinetic energy in joules given. When the radiation of frequency is given, now he is asking threshold frequency. That means the energy can be written in which word? Frequency term. So that you can write kinetic energy equal to E minus E naught, that we can write H into nu minus nu naught. He is asking nu naught. We have H value, nu value, kinetic energy. So substitute. Kinetic energy, how much value given? 1.986 into 10 power minus 19 joules. This H value 6.625 into 10 power minus 34. This is nu minus nu naught. You can keep like this. Simplify చేయండి. Then nu minus nu naught. 1 into 1.986 by 6.625. ఇది ఆల్మోస్ట్ 3 అమ్మా. 1/3 0.3 వస్తుంది. సరే సింప్లిఫై చేయండి. ఇక్కడ వచ్చినాక న్యూ వాల్యూని సబ్స్టిట్యూట్ చేయండి. ఓకే, దిస్ యూ కెన్ రైట్ 1.986 by 6.625 into 10 power 15. ఓకే, సో న్యూ ఈక్వల్ న్యూ నాట్ మనకు కావాలి. న్యూ నాట్ కావాలంటే దీన్ని పంపించండి, దీన్ని పంపించండి. న్యూ వాల్యూ వీ హ్యావ్. ఇది ఎంత వస్తుందమ్మా చెప్పండి. న్యూ వాల్యూ గివెన్ 10 power 15 మైనస్ ఇది కూడా 10 power 15లోనే రాయండి. ఇన్ ఫ్యాక్ట్ యూ కెన్ టేక్ కామన్ అవుట్ 10 power 15. ఈ వాల్యూ ఎంత వస్తుంది చెప్పండి. ఇది 0. అరే ఇది 1/3 0.3 వస్తుందిరా. ఏంద్రా మీరు, ఈ వాల్యూ 0.3 వస్తుంది. సో 1 minus 0.3. దిస్ యూ కెన్ రైట్ న్యూ నాట్ ఈక్వల్ టు 0.7. దట్ యూ కెన్ రైట్ 7 into 10 power 40. ఈ 6 3 18 కదరా. కొంచెం వాడండి రా. ఓకే, నెక్స్ట్ క్వశ్చన్. అంతే 0.3. రైట్, నెక్స్ట్ క్వశ్చన్. అమ్మా మీరు ఏం రాయొద్దు, వాళ్ళే పంపిస్తారు, అందులో చూసుకోండి. ఓకేనా, జస్ట్ వినండి. ద ఎనర్జీ ఆఫ్ అన్ ఎలక్ట్రాన్ ఇన్ థర్డ్ ఆర్బిట్ ఆఫ్ హైడ్రోజన్ ఆటమ్, En equal to we gave in joules he is asking. Minus 13.6 z square by n square. Minus 13.6 into n square means third orbit, right? 9. ఎంత వస్తుందమ్మా? Minus 1.5 electron volts. But 1 electron volt equal to 1.602 into 10 power minus 19. 16 into 16. 2.42 వస్తుంది. మల్టిప్లై చేయండి రా. 15 6 జా 90. 15 6 జా 90 అంతేనా? సింప్లిఫై చేసి రాయండి అమ్మా. ఓకేనా, రైట్. అరే క్యాలిక్యులేషన్ పార్ట్ మీరు చేయండి. ఓకే, ఒక్కోటి చెప్తూ ఉంటారు, ఇదే మీకు ఛాన్స్ ఇస్తే. ఓకేనా అమ్మ, వద్దమ్మా మీరు చేయండి. చేసినాక అప్పటికి రాకపోతే మీరు బయటకు వెళ్ళేటప్పుడు క్యాలిక్యులేటర్ యూజ్ చేసుకుని చెక్ చేసుకోండి, మేము చేసింది కరెక్టా రాంగ్ అనేది. ఓకేనా, ఇంక ఇవి కూడా ఈ ఎడిషన్స్, సబ్స్ట్రాక్షన్స్, మల్టిప్లికేషన్స్, డివిజన్స్ చెప్పారు అనుకోండి, నన్ను మామూలుగా చూడరు. నెక్స్ట్, ద ప్రొడక్ట్ ఆఫ్ అన్సర్టనిటీ ఇన్ పొజిషన్ అండ్ అన్సర్టనిటీ ఆఫ్ వెలాసిటీ ఆఫ్ పార్టికల్ ఈస్ గివెన్. If the uncertainty in position is 1 nanometer, what is the uncertainty in measurement of velocity in meter second inverse? చూడమ్మా, దిస్ ఈజ్ యాజ్ 1 అని చెప్పేశాడు రా, 1 నానోమీటర్. This is h by 4 pi value. You can substitute. Delta x m into delta v equal to h by 4 pi. దీని వాల్యూ వాడు ఇచ్చేసాడు ఎంత? 5.79 into 10 power minus 5. Delta x 1 nanometer. You need to convert into meters. 1 nanometer means 10 power minus 9 into mass of electron 9.1 into 10 power minus 31 into delta v. We don't know this value. This is given 5.79 into 10 power minus 5. Simplify and solve the question. Particle is not mentioned. Mass చెప్పలేదురా, అదే తప్పు ఉంది. Question itself wrong. Okay, it's not an electron. The particle he gave. Question ఈ అమ్మాయి టైప్ చేయడంలో ఏదో వదిలేసింది ఒక వర్డ్. ఇది చేయొద్దులండి, నెక్స్ట్ క్వశ్చన్కి వెళ్దాం చూడండి. Maximum number of electrons in subcell n equal to 4, l equal to 3. L equal to 3 means L equal to 0, 1, 2, 3 we gave. This is for S, this is for P, this is for D, this is for F. The maximum number of electrons, 14 electrons, because F contains 7 orbitals, 7 into 2 equal to 14. Right, next one. From the following sets of quantum numbers, which set is possible? N equal to 1, L equal to 0. Okay, K cell contains S sub cell, but M can have the value 0, so it is not possible. N equal to 1, L equal to 1 means P. M can have 0, minus 1, 0, plus 1 can be possible. MS is plus 1 by 2. Yes. N equal to 1 should not be, because p orbitals are not started from K shell. So this is incorrect. While coming for N equal to 3, L equal to 1, this represents 3p orbital. Okay. This is 1p orbital, does not possible. While ML equal to 0, possible. Minus 1, 0, plus 1. M equal to plus 1 by 2, possible. 3p we have. N equal to 3. This is L equal to 3. This is 3f, does not possible, because f orbitals are starting from 4th cell. So it is not possible. Well, coming for the next one. Which of the following relations is correct if the wavelength is equal to the distance traveled by the electron in 1 second? First option, lambda equal to h by p. Yes, good. For an electron in the d orbital, the orbital angular momentum. I gave the formula. Orbital means angular momentum. That is mvr equal to root over L into h by 2 pi. For which orbital he gave? D orbital. For d orbital, L value 2. So that you can write 2 into 2 plus 1 into h by 2 pi. This is, you can write root 2 into root 3 into h by 2 pi, you can write. If it is directly given root 6 into h by 2 pi, you can go directly, no problem. This is root 6 h by 2 pi. Ela ichina correct. Otherwise, dini 2 into root 2 raskondi. E root 2 cancel ayyindi. That is root 3 by 2 into h by pi. Etla ichina correct. Okay. The next question. Heisenberg uncertainty principle is general significant. Then significant chestadi. Microparticles kada. Microparticles heavy, having very high speed. Very good. Next one. The orbital with 4 radial and 1 angular node. Radial node formula n minus L minus 1. Angular node means L. How many angular nodes is given? 1. 1 indicates L value 1 means P. That must be P subcell. How many P subcells we have? This is 5P, 6P. Compare these two. For 5P, n minus L minus 1. 5 minus 1 minus 1 equal to 3. For 6P, 6 minus 1 minus 1, 4. He is asking 4 radial nodes. So you can go with B. Confuse avaddu. Meeku endalu cheppinive radial nodes ki spherical nodes ki formula idi. Node angular node ki formula L. Okay, you can go with B. Ivi formulas. Okay. Right. All coming to the question. The product of uncertainty in the position and uncertainty in velocity of particle. Same thing we gave once again. As we did already. First question is it. Okay na? Already rasin. Malli endra antam ikkada lera. First question ide kadara manam discuss chesindi. Right? Up to this extent, atomic structure, one chapter is completed with examples. ఎందుకంటే మీకు నేను స్టార్టింగ్లోనే చెప్పా, ఇక్కడ సినిమా అంతా డిఫరెంట్ ఉంటుంది. మీరు దానికి తగ్గట్టుగానే ఆ సీక్వెన్స్ ఏవైతే వస్తుంటే దానికి తగ్గట్టుగా నువ్వు స్పీడప్ అవుతూ ఉండాలి. ఓకేనా? రైట్. మీకు హోంవర్క్ ఆల్రెడీ మీకుండే యాప్లో అప్లోడ్ చేశారమ్మా హోంవర్క్. ఆ హోంవర్క్ మీరు చేయండి. చేసేటప్పుడు మీకు ఏమైనా క్వశ్చన్స్ రాకపోతే వీడియో సొల్యూషన్స్ ఉన్నాయి వర్చువల్గా, అవి చూడండి. అప్పటికీ రాకపోతే వచ్చేటప్పుడు క్లాస్కి వచ్చేటప్పుడు ఒకసారి అడగండి. ఓకేనా? రైట్. హ్యావ్ ఏ గ్రేట్ అండ్ వండర్ఫుల్ డే.